All right. Hi, everyone. My name is Mihai Dontu. I work for Bitdefender, and I'm going to present something that I've been talking about at every presentation I've had for Xen Summit since 2014. Every time I went in front of the developers and talked about the feature that we wanted to push into Xen, and we used this argument that we have this internal project called HVI that has this feature that really requires this change in Xen. So I'm pretty sure at least once or twice people have wondered, what on earth are you guys doing there? So this time, after we've managed to flush our entire queue of changes for both Xen and KVM, it is time to move to the actual beast, which is the core technology for HVI. The reason for all our changes in Xen. Let's move right onto it. So HVI, or hypervisor-based memory introspection, is a technique of analyzing a VM and what's going on inside of it from outside, using the ability of the hypervisor to tap into the memory state of the guest that it's running. It can identify today pretty much everything that's going on, like basic things like the operating system that's been done over and over. But it can extract processes in their entire state. It can do really deep analysis for certain operating system specific things. Like, for example, it can check if certain applications have a certain Windows specific feature enabled, like data execution prevention or something like that, many other things. So it can pull outside into an application that uses HVI, can pull from a virtual machine all the information necessary so it can begin and build a security layer starting from that. Obviously, given the name, it uses memory to do most of its work. And specifically, it uses Intel's EPTE to set hooks on various parts of the either the guest kernel or the applications running on top of it, or it builds currently a very accurate image of the entire page table set up by the operating system. It does that. It has a shadow page table and use it to figure out everything that's going on in an application. Mostly applications like browsers are what people are, let's say, really trippy about, right? So the biggest challenge in building HVI is to build the semantic gap, which means having access to raw memory, figure out where everything is, right? Except, especially since today operating systems randomize everything, right? And doing this in real time, that is, the engine can track a guest, and you don't really feel that it's doing that. So doing that in real time requires all kinds of tricks to shorten the round trip from the hypervisor to introspection engine back to the guest being introspected. So there's a balance of many things in there, from optimizing a bunch of code paths, but also picking exactly what to look at, right? You can't just put a hook everywhere, especially if, let's say, you're looking for modifications, but you're looking in a location where the kernel or the application makes changes frequently. So you have to come up with some other solution. the way when we went public with HVI, the way we envisioned it working was in a user space application running in a separate virtual machine that we deemed as being a security virtual appliance. And from that security appliance, that application running in that security appliance would monitor every other guest running on top of the hypervisor, right? Xen in this specific case. Today it supports KVM as well, and given that it started as part of NAPOCA, by the way, a presentation that two colleagues of mine, Raul Tosha and Daniel Zikl, gave yesterday, it's basically where inside of which it grew initially, and then it split into a separate project. So what is HVI? Essentially is a library, right? Today, the solution that we have out there for Xen server or the Citrus hypervisor today, it's packed as a simple shared library. It doesn't have any dependency on the operating system. It goes even further. It has its own C runtime, right? And it redirects things that just cannot do on its own, like, for example, memory management, to the integrator application. So it has this API for which the integrator has to provide various callbacks. And they match pretty well with what I guess a lot of people are familiar with libVMI. So that API matches pretty well with what libVMI offers, with maybe one exception. I've talked about this many times. Page sharing, right? Mapping guest pages into the security virtual appliance. That was deemed by the libVMI developers as being a niche feature, and recommended that every integrator does it specifically for the hypervisor that it targets. And it's not really a big deal. The way page sharing works in Xen, it's pretty simple, so everybody can do it. What we actually did on top of it is add a little bit of a cache, because mapping and unmapping happens quite frequently. All right, so once all the glue is set up and everything is initialized, the introspection engine is essentially event-based. It does one single swoop through a limited part of the guest memory. It takes about maybe even less than a second to figure out everything. And then using various hooks and various points, it builds kind of an event machine. And as, for example, if the engine is enabled when the guest boots, it builds its entire map of everything that's been loaded, kernel drivers, services, whatever, in real time. If, on the other hand, it's been enabled later, after the guest has already booted, it does a full scan immediately and builds a shadow of the guest state. The project started internally around 2012. As I said, it was part of an internal hypervisor project. That was, let's say, an educational project initially, but it became something quite serious as time passed. As the engine grew and we saw ways of using it with different hypervisors, we split it into a separate project, and it had initially support just for Windows 7, 32 and 64, and it only aimed to protect the kernel image, the non-pageable part of the kernel, and obviously, since you lock down the kernel image, and being a security company, you're obviously looking to prevent or rootkit from setting a foothold inside the guest. And around 2013, we started spamming the Xen Devel mailing list with all kinds of scary features, for which were some very justified reactions initially. That it took us a while to figure out a way to communicate outside of our mentality, like being a security company, to explain clearly what we were aiming to do. And I think for those that have seen my previous presentations in the past years, one of the things we've let's say stumbled upon were limitations in the x86 emulator. Today is in a much better state, but back then there was no. It did what it needed to do. I think it was mostly for probably device emulation, for which a limited number of instructions were more than sufficient. But lo and behold, comes introspection, and given that back then there was no, for example, alternate EPT views, we had to set hooks, and then in order to be able to allow a guest to function normally, but without removing the hooks, we do some emulation tricks. Okay. So as around 2016, we decided to build a relationship with Citrix, and we bundled everything. We integrated everything with our bigger security solution called Gravity Zone, and announced it right to the world like a fully mature project that everybody could deploy in their environments. Around 2018, we started pushing some patches for KVM as well, and at the same time, because there are separate teams that work on hypervisor integration, introspection engine development, and the other team working on the POCA development, the internal hypervisor. So we added all kinds of features, right? The most complicated one being support for monitoring and providing protection for user space application, mostly like browsers and Office applications, so on and so forth. That was quite a complicated task, especially because a very complicated part of the memory management of the operating system comes into play, and you need to so for example, you want to look at something specific that's been paged out. You cannot pull it from a page file by yourself. You have to notify the kernel and again go through all the necessary steps and wait for the kernel to bring it. And you have to maintain all kinds of states along the way. And with this effort to expand protection to the entire operating system, we managed to provide add protections day one, so to speak. So when these exploits, EternalBlue, BlueKeep, SMB Ghost, were published, HVI, the product built around HVI, caught them immediately. So proving to ourselves firstly that yes, the technology we're working on really does, and it's proving itself, right? And I think I'm going to give control to Andrei Lutas at this point.
Yes, thank you, Mihai. Can everyone hear me? Yes, we can hear you.
Most excellent. So, hi everybody. I'm just waiting to, all right, now I have controls. So Mihai covered a little bit of ancient history with regards to what we've been doing with this neat and ambitious little project. As far as what it can actually do, the introspection engine supports pretty much all Windows operating systems starting with Windows 7 up until the most recent Windows 10s, including those which are in Insider Preview. We support both 32 bits and 64 bits Windows, and we support 64 bits Linuxes, in particular Debian, Ubuntu, CentOS, Red Hat, OpenSUSE, Oracle Linux. However, adding support for other operating systems is pretty straightforward. And in fact, as you will see in a few weeks, we have dedicated tools and scripts which can automatically add support for a new operating system. So you don't even have to reverse engineer anything. You just have to run a script and voila, that operating system is now supported. Because the operating system support files are just some kind of configuration files which are compiled into binary format and fed into the main introspection engine. So we support protection for kernel modules, kernel structures, and some predefined processes, just like Mihai mentioned, mostly browsers, Office, some server-specific applications, in particular, those kinds of applications which are being targeted by attackers and are predisposed to being exploited. So what do we do? Well, in a nutshell, we intercept hardware events, right? Whatever the CPU provides and the hypervisor exposes, we're going to use it one way or another. We're going to leech it somehow to extract information from it. And we can intercept control register accesses, model-specific register accesses, of course, memory accesses, which is the bread and butter of HVI. We can intercept exceptions that are taking place inside the guest. For example, when a breakpoint takes place or when a page fault takes place inside the guest. And then building on top of this, we have OS-specific events, which are obviously based one way or another on the hardware events. And for example, we can get such information from within the guest, like loading or unloading kernel modules, process creation and termination, modules being loaded or unloaded inside processes, allocating virtual address descriptors, and so on and so forth. The introspection engine also has a pretty cool abstract guest memory architecture. So if you wish, for example, to monitor, let's say, a virtual address inside the guest, you don't have to care about paging inside the guest. Everything is done internal by HVI. It will make sure it intercepts the page tables. It will make sure that every time the translation of that virtual address is changed, the protection inside EPT is maintained. In addition to this, we also have this cool little feature which allows us to access swapped out memory. And we don't do this by accessing the disk in a way. In fact, we do this by basically persuading the operating system to swap in those pages for us by injecting page faults inside the operating system. So what can we do using all of this? In particular, the kinds of attacks that we are trying to prevent are the following. Kernel rootkits. This is how the project initially started almost 10 years ago. We tried to prevent certain rootkits from modifying some very sensitive driver objects. For example, the TDR rootkit. And this is how it all started. And in fact, the first iteration of the introspection engine could only protect a couple of non-paged driver objects, and that was it. In the meantime, we expanded our visibility and our area of expertise with regard to kernel rootkit protection. We provide protection for loaded modules from being tampered with, preventing inline hooks inside kernel drivers, preventing system service dispatch table modifications, IDT, GDT modifications, and so on. Then we have the kernel exploit protection. And this is where we have several kinds of techniques implemented. And just to give you an example of how ample these techniques are, if we look at how the EternalBlue exploit works, there are 4 different steps that HVI can block during the exploitation phase. So of course, all you need to block is one single step to make it unusable, but in theory, any kind of exploit that uses any one of those 4 steps will get blocked. We aim to prevent local privilege escalation by preventing execution from various sensitive areas, for example, from the Windows shared user data, by preventing the supervisory mode execution prevention and supervisory mode access prevention from being disabled from CR4, and so on. User mode exploits, of course, one of the main capability of HVI by preventing code execution from dubious areas inside processes, function hooking inside DLLs, and we also have credential theft, where Mimikatz-like behavior is blocked by prohibiting access to the credentials stored inside the LSASS process. In addition to this, we also have operational information. We can give information about process activity, driver activity, and in case we detect something, we can even provide the full list of TCP/IP connections. We also support the latest Intel virtualization technologies. We have support for HashV and VMFunk. In order to accelerate page table monitoring, we can deploy a very small filtering agent inside the guest, and we can mark all the page tables as being convertible pages and have a HashV inside the guest instead of an EPT violation to the SBA. We also have support for SPP, which we would gladly like to have in Xen, one way or another. And we are, of course, considering future technologies such as HLET as well, and even older technologies such as mode-based execution controls to add support for them in HVI. The project is in active development, both from the perspective of adding new protection capabilities and from the perspective of adding support for new CPU and virtualization capabilities. But we are not here to brag about what HVI can do, because you can see it for yourself starting with July the 30th, when we will make source everything. So all that we've done in the past almost decade will get open sourced. The introspection engine with all of its capabilities, with everything that it has, is going to be open source in a couple of weeks or so. It's going to be open sourced under the Apache 2.0 license. And the idea behind this is that we wish to create a community of security researchers interested in this topic, which can come up with new features which can be implemented in HVI, with bug fixes. Of course, we are aware of the fact that nobody writes perfect code, and we are nobody. And of course, we are very, very curious about crazy new use cases for HVI. Even we have some crazy ideas that we can't wait to make them happen in practice, because HVI has so much potential that we are sure that someone somewhere is going to be very glad when he's going to see everything coming up as open source. So, in conclusions, 10 years worth of technical ingenuity is going to be public on the 30th of July. HVI is going to be a sub-project of the Xen project. We can't wait to see how the community embraces this project. We accept the backlash when some people will see what we have done with HVI. They're going to go, what the hell is this? But it's cool, it works. It was one hell of an adventure, and we are very keen to see how this moves forward. New use cases are very encouraged, and we can see what the community comes up with. Thank you very much. Questions? I think the announcement of us making it open source came as a shock for some folks. So
Wow, it really is tumbleweeds from the floor, isn't it?
Crickets in the background. Well, we hope it's not gonna be that quiet once we publish everything. We already have a Slack channel which we will make public once we go open source, so everyone can join in and just start chatting about this topic.
Well, what are some of these crazy ideas you've got then?
Well, I can't talk too much about it. It may involve forensics, sandboxing kind of things, but I won't go into more detail for now. We'll wait for it to become open source and see from there on.
Fair enough.
So, I mean, I think this is cool. Unfortunately, I don't have any questions about that. You might, if there's a graphic that has kind of an architecture or anything like that, that might provide people with something to, like a thing to get ideas to ask questions from. But if not, then we can.
So yeah,
3 minutes.
We don't have it right now, but the project is very well documented, we like to believe. So once everything goes open source, hopefully there's going to be enough info to start with. The project should have been open sourced already, but we had to delay due to several reasons. The initial plan was for the project to already be open sourced by the time we give this talk. Unfortunately, it had to be the other way around.
Presumably the lawyers got in the way.
I cannot deny nor confirm that.
Don't speculate.
Right, well, that appears to be everything, in which case, thank you very much for that presentation.
Thank you very much for hosting us. Bye.